Hello, I want to demonstrate an interesting use case of Immuta fine-grained access controls on genomic data, specifically VCF data. So what we've done here, before I get into this, what we've done here is load a series of VCF files into data structures in Snowflake. So we place those VCF files into a tabular format that we can analyze, and more importantly, apply fine-grained controls on who can see the data, why they can see it, and how much of it they can see. This is really interesting because we're able to apply controls not just at the coarse-grained file level, but we actually can get into it and remove specific portions of the genome or perturb portions of the genome based on privacy conditions and what the patients would like. So in this hypothetical, let's say we have two patients that we have their genomic data, but they've asked that their genomic data only be used for the purposes of studying colon cancer. So what we can do, if we want to implement that policy, we can look up using support tables, what are the indicators, what are the markers for colon cancer, and anywhere in the full VCF file that is consistent with colon cancer, we can allow these patients' data to come through. But more importantly, if it's inconsistent with colon cancer, we can redact those patients. And to do that, we use what's called a row redaction policy in Immuta. It is also called row level security. We can define a SQL predicate that basically defines the criteria under which we show a table. So when this SQL predicate evaluates as true, we'll show a row. If it evaluates as false, we'll remove that row from the data set. So we have this case statement where we look for when the marker is consistent with colon cancer. If that's the case, just show everybody. If it isn't, then if the sample ID is consistent with either patient 113 or 145, remove those rows from the data set. So we can see this impact in Snowflake. So we have this policy defined. This is enforced in Snowflake. So if I wanted to query the entire data set, you see a pretty dramatic effect here. As we look at our patients and we sort by the total number of variant calls we have for them, and you can see a huge drop for these two patients. And that is specifically because all their data has been removed except for those markers for colon cancer. So if you wanted to do a colon cancer study, you can run a query like this, look for these colon cancer markers, and run it. We get the full data set. We can see allele counts going forward. We can also look specifically at these two users and run our normal query, our normal analysis. That comes through, no problem. But let's say I switch. For whatever reason, an analyst wants to look at retinal dystrophy. They'll run this query, and they'll still see a fairly sizable data set that they can do an analysis on. And it won't be clear to them that they have not seen results for these two patients. In fact, if they would run a query where they say, don't give me everyone but these two, they'll see the exact same result. But let's make it more explicit. If they wanted to hone in on these two, then they see nothing. And so really what's happened here is we've removed these two patients from anything queryable by this analyst. So any query they run that is unauthorized in some sense will automatically remove these two patients from the data. And so we've been able to preserve the patient's desires and their consent while still enabling analysts to do their work. Thank you.